Kia ora everyone, welcome to the Timber Design Society webinar series in May. The mill today, a building in Queenstown, and we're hearing a builder's perspective on the benefits of mass timber construction presented by Josh Gibbons. As usual, a great thank you to our sponsors, Rotoblast, Eurotech, iBuild, XLAM, Simpson Strong Tie, TechLam, our new sponsors, TimberSpan and ProLam, for continuous contribution and support of the Timber Design Society. As usual, if you, as a design community, have any topics that are on your chest and you'd like to have answered, or you would like to hear more about, just let us know by scanning this QR code and providing your feedback to us. And the upcoming events, you might have heard it, which are pretty exciting, are the Timber Design Awards in June this year. And before we're kicking off the gala dinner on the 26th of June, we do have a seminar throughout the day, and we're looking at Timber Delivered, basically a short summary and a detailed projection on 5 live projects and how they've been developed and led to success. But now let's come to our presenter today, Josh Gibbons. And let me introduce you to Josh. Josh Gibbons is the Southern Lakes Regional Manager at Cook Brothers Construction with over 20 years experience in New Zealand in the construction industry. His career spans from hands-on carpentry through to executive leadership, providing a practical, delivery-focused perspective across all stages of the project. Josh has a strong interest in design-led delivery and is committed to building high-performing teams that achieve the strong outcomes on complex projects. So let's kick off with a complex project today and welcome Josh to start his presentation.
Thanks, Bjorn, for the great introduction there. I probably want to start with really is I don't think mass timber isn't the silver bullet that solves all of construction sustainability challenges, but it's a pretty awesome place to start in the conversation. I say that because I want to be upfront about where I'm coming from. I'm not telling you that timber should replace everything. I'm not here to sell you on anything either. I'm here because we built something in Queenstown that I think tells an honest story about what mass timber construction really looks like. The good parts and the bad parts, or the hard parts, as you'd say. And I think honesty in the construction sector is really what's needed now. The lessons to learn and how to get people inspired about doing something different. So, as Bjorn said, a little bit about me. I've been fortunate enough to work my way through the construction sector from a carpentry base, which is going to be great grounding in terms of my role today as regional manager. I'm not a timber engineer, a BIM specialist, and definitely not a sustainability expert. But the part of which I do know is how to put things together from a construction aspect. And, you know, a lot of confidence in that space too. But I can tell you that this job definitely pushed us outside our comfort zone. And, you know, it was something that, for me as a builder, was such a fantastic thing to have happen. You know, going back to roots of working with mass timber and timber construction as a whole. I love working with timber. I love the way it's put together. I love the way you can hold it and grasp it. You see the forest where it comes from, and then seeing that go into a live building. More so in this case when the structure's on display. So with everything, I'm not an expert. So take what I present today in that spirit. And if you have really technical questions, I'm sure that Bjorn and the rest of the TDS Society will be able to answer some of those in the future. But for us, I think we can cover a fair bit of ground about what it's like to deliver a building like this, the challenges you face, and then the lessons we'd put into the next one. So with that in mind, the mill is Queenstown's newest sports performance and recovery centre. It was situated in Frankton at the foot of the Remarkables Mountain. 2,500 square metres, around 18 million in build cost, and about 2.5 years in the making. It opened in June last year, and it's already become a genuine community hub. the brief was really ambitious from the start. The clients wanted a world-class facility where elite athletes and everyday fitness enthusiasts alike could go along and work out together, get treated together, really have this contrast between a gym and then this recovery area, but also clinical spaces as well. So there's a 1,200 square meter gym, 25-meter indoor turf running track, an outdoor running track as well, spin studio, high intensity studio, contrasting therapy zones, recovery rooms, and clinical consultation areas for physios, podiatrists, nutritionists, and performance coaches. It was all under one roof. It was, in the words of Pete Forsch, the general manager or director, it was more than just a gym. The mill is a place where movement, recovery, health, and community come together. Anyone can go there. And I do encourage anyone on this call, if you're in Queenstown, head along. The team there will look after you really well for a drop-in session and get to see what it's like working out in a gym like this. As I start, the concept on the left here is the hand-drawn sketch from Warren and Marnie early on in the stage. And it shows sort of like the indicative start of this project and where it all was grounded in. And then as we work through, such an awesome backdrop to be working within, and in Queenstown with the airport so close, a lot of constraints and challenges, but looking up at that mountain every day was probably something the team thoroughly enjoyed, as well as the timber. So the design from Warren and Marnie is a very striking building. It's a sawtooth roof line, and that's the first thing you really notice when you get to the building. And that building is really, or the structure is really doing all of the big lifting. And obviously the sawtooth environment allowed a lot of natural light into the training spaces. So it wasn't just decorative, there was a plan around it. The primary structure is glulam beams, columns, and purlins designed by a homes group in Queenstown, with the timber manufactured offshore in Austria by Weehawk. Pal Fenwick were the services designers, and they ensured the right environment inside the building was going to match that on the outside. So our project team from day one was really committed to making sure that mass timber was going to be the right option, and that how we treated that build environment was one with real care and consideration to where things were going to go, how the grid lines were going to look, how you're going to maximize this timber structure, but also allow it to do what it was supposed to do, would take the load, while also making sure that the services moved around it to not detract from this mass timber. We were brought on in early contractor involvement engagement, and I think looking back, that was probably one of the big decisions in the project that really paid off. Obviously, finding a really good design team is crucial, and that was already there. But then for us to come in and really help the construction team, or the design team, from a construction perspective, was probably something that made this project fly as well as it did, and it gave a really good sort of lead in to make sure we thought of everything in terms of the mass timber elements. So with that sort of thing in mind, I'll move into what really went well on this project, and going back to this design team. And what they did really well from the start was they designed it in timber. And that sounds really like cliche and pretty straightforward and standard, but the thing with mass timber buildings we've found, and from talking with the industry a lot, is that if you try and chop and change them and you move into timber later, or you design in timber and then move away and go back traditional, it's such a harder process to do. You lose all the benefits and the efficiencies. The design is got to be centered around this mass timber being the grid lines and the elements to build from. So WAM did a fantastic job in terms of this space. As you can see from their initial concepts, the structure was going to be on show. It was going to be the main thing. It was going to do a job, but it also was going to be on show. So probably not what you'd normally have for a typical gym. And so that's the challenge that WAM had, was how do you create this space of connectivity and a feeling of nature, I suppose, with all the light around the outside, but also having that timber staying as the core element. And I think for us coming in at this stage where this design is already locked in, those grid lines were set around what the mass timber could do in terms of its spans and its heights. That was done. So for us, we didn't have to come and try and reinvent the wheel in that space. Our designs or our decisions were not really reacting to that design. It was more influencing the next stage of that. So flagging buildability issues before they become really expensive. And then the key part of that as well, bringing broad in so early, is building a strong relationship with that design team. Much easier to build a relationship when you're at the early stages of a project and things are relatively smooth sailing compared to when you're in the delivery phase and there's a lot of pressure coming on the team. So if you build those connections early, you understand how everyone operates, then you kind of get rid of that, so those kinks from a later part of the project. So the good part of this design with timber from the start, it meant timber supply was a key aspect, and bringing them in was really crucial to make sure they got the timber size correctly, finishing grades and structural connections to all work. So yeah, the timber from the start, it's got to be probably one of the top decisions I think the team made early on. BIM, and how, as I said, I'm not a BIM expert. I'm not fluent in doing anything related to those models on the screen, but I know how to read them and look at them and understand it from a buildability perspective. And I think for us, the BIM coordination isn't optional in mass timber. It's how the whole thing works. And with the design for manufacture coming into the play, for us, it meant that this thing was designed so well at the early stages and in the 3D environment where you could actually move around and understand how the connections worked, understand where everything flowed, understand how you're going to sequence the project. So for the timber components were fabricated in Austria, we had to make sure that everything worked. The ones that got to site, it was a lot harder to change it. There is no fix on site sort of mentality, I feel, with mass timber, and it needs to be that way as well, because you want to iron those things out early, because it creates so many other challenges later on. So regular coordination meetings were incredibly important. Our design team, led by Stuart Mitchell from our side, he would be up at 4 a.m. with the guys in Austria, going back and forward in a lot of detailing, understanding where things were all going, understanding sort of like the timber element, how it's going to connect together. One thing we did really early in that coordination was look at integrating the purlins into the package and having them all pre-cut, pre-done, so it was like a Meccano set coming on and slotting all together. It was a really, involved process from everyone. And when we were fortunate enough to go and meet Weehag in Austria, there's a photo of Stu there, like literally hand drawing a final chamfer detail on one of the beams, because we're trying to figure out how we're going to get the beams and the bolts all working together in one of the top nodes. It was had about 8 pieces coming into one point, and we started looking at how much we could shave off. And we're talking like 5 millimeters here, not talking in 30s or 50s. It was like down to those sort of minor details. But doing it in person with the model on the screen, and then Stuart drawing by hand, it was like such an awesome experience to sit back and watch, and hence why I took the photo. But this sort of understanding of this digital environment gave the team on site a whole lot of confidence in how things going to fit and when it all came together. So fast forward to the timber installing on site, and this is one of the moments you never forget. All that preparation that you'd done, all that hard work in terms of getting it to where it is, had now come to fruition. So there's something about watching a mass timber building go up that is sort of, as a carpenter, is quite special. It's very different from steel and concrete, as the site feels different and the team engages a lot differently. It's definitely a lot quieter as well. And this timber, for a particular, I was incredibly nervous with. And I think it was more so the fact that during the design phase, we'd come up with an option to mitigate some risk in terms of the base plate connections. I was really concerned around getting the timber on site, and for whatever reason, things not going to plan, because you've been in the industry as long as I have, and I'm sure there's people on the call, you plan for the best, but you always expect the worst. And so I was nervous around the base plate connections and how they're going to go together. So with homes, we designed a drossback filled hold down bolt connection where we could actually have tolerance to move the base plates around. And then once everything was locked in place with the timber, we could grout those in later. My team had other ideas. They felt that the speed was going to be disadvantaged because of that, and went about creating a system in which they felt comfortable grouting all those hold downs in place. So we went old school and dumpies, theodolites. We got surveyors out to do digital grids, and then also had Stuart Mitchell doing his own Q&A checks as well to make sure these base plates were all in the right location before grouted in. So I can tell you right now, I didn't go on site for the first timber install at all. I was way too nervous, but I watched it from our camera, which is in our office, and watched it being installed. And surprisingly enough, it actually went really well, which all the planning in that would tell you it did, but you just never know. And then from there, the speed was just absolutely incredible. 7 weeks from first timber going up to complete of all timber structure. And I think for us, we were thinking it'd take us about 12 weeks, and it really just blew our minds about how quick it would go once really well planned. I think that's the payoff for all that really, really good planning. The other part of the planning for us that we kind of didn't really think about at the time was the sustainability aspect. Now, in this, we decided to do a case study on the build as a whole. And it's something that I'm incredibly proud of because the mass timber drove us in a direction of sustainability and thinking about that. But what did it actually mean in terms of metrics? And for us, this project still generated a heap of waste, even with that sustainability aspect of the mass timber. As you can see from the slide, there's a whole lot of waste generated. And out of that, Christy Jones, our sustainability manager, tipped out 38.4 tonnes or 33 skips of waste and went through them by hand to understand what it was we were throwing out and what it was that probably through education could be changed. And what we really found was there were about 3 core aspects. Design adds about 30% challenge to sustainability and waste diversion. Construction takes about 40 to 50%, and the balance is taken up by supplier engagement and packaging and that sort of carry on. So from this and our lens and focus around sustainability, we managed to divert 47% of the waste of the project from landfill. Now, as you'll see, 82% is our including clean fill stat, but I like to look away from that because I think that doesn't really address the true challenge here. The challenge is in actually what is the waste that we're generating on our projects. Soil and that sort of thing can be pushed around to other projects and moved off site, which will increase stats, but doesn't really help us address the elephant in the room, which is all the things we generate. So I think it's a great result which we've got here. But as you can see in the middle, there's stuff we can still do. And the amount of waste that was that could have been diverted from landfill was still significant. And that was mostly through education. But the next thing is how do you go from diversion to minimization? I think that's the thinking and the logic that needs to change as we start to adapt in the construction sector and understand we've got a bigger place to play in that. So yeah, definitely a lot to learn. And I know that Christy's actually going to start going through sharing this knowledge throughout the construction sector in multiple different avenues. So I'd definitely advise you if you want to hear about that or go attend one of those webinars she's doing or in person, hit her up. Her email's there on the bottom or her phone number as well. So I've sort of spoken through the 4 elements I felt were the things that we thought went really, really well and we loved. So let's dig into the stuff that's really the key parts of what makes these jobs more challenging. So for us, moisture management is a phrase that got bandied around really early, and everyone was super nervous about this. No matter how well you plan, you're always going to have something come up. But I think the adage of failing to plan is planned to fail came true, because if you didn't have a plan, then when something did crop up that was different, it would have been disaster, I feel. So for us, we knew that our install window was going to be really challenged. It was midwinter, and so the potential of snow and rain was high. Everyone in the design team was nervous, client was nervous, we were nervous. So what we did, we developed a 40-step process inside our moisture management plan. There's around 6 iterations of this before we actually locked in what we're actually going to do. And then this also was in parallel with the design team helping out a lot in that, and calls back to Austria as well, what they'd done in the past. Everyone was nervous, the plan was in place, and then snow happened, as you can see in that bottom photo. So with all the great planning, all that stuff going on, you still come up against roadblocks. Now, the plan we had around moisture management was to firstly understand where the moisture is at. So we had moisture readings in Austria before it got on the boat. We had moisture readings at port when we're devanning, as you can see Matt do in the middle there. And then continual moisture meetings on site during install right up to when we were weather tight. Now, part of this planning and this moisture management was around creating these skirts at the top and these kind of top hats, we called them, to protect those end grains of the moisture, of the beam, from moisture. Now, we also created skirts around the bottom of the timber where the V's come and join together. The top hats worked really, really well. Great option, allowed enough air around, it kept that top really, really safe and secure. The V's, however, the little skirt started to create a whole lot of moisture and a whole lot of humidity underneath. And so while trying to protect the timber, we actually started to create an environment which was not great for moisture management. Water was coming down and running off the V's down into the grooves and then splashing off the ground inside this sort of tent and then throwing up contaminants back onto the timber and started to mark it in a way that wasn't great for the long-term view of the project. So with a number of calls with the guys in Austria, the timber sort of industry, also the structural engineer and architects here, we came up with a plan just to take them completely off, leave the top hats on, but take the skirts off the bottom and use a blower method of just continually keeping those areas dry and free from water. So I think we hadn't had a plan, we wouldn't be able to move as quickly as we did to understand what we could have done to remediate that. But as I say, the challenges definitely are there in terms of moisture management. And I think that leads into the next one, which is protection. Protection is incredibly hard when your primary structure is also a finished element. And the analogy I put it to would be like putting your kitchen in your brand new house in and finishing it off when the roof's just going on. Like that's sort of the mentality you have with the mass timber. You know, you'd be an insane person to put your kitchen in when you hadn't put your linings on and you were still trying to, put the cladding on the outside, get the windows in. But essentially you're doing that with a mass timber building, right? And so especially when it's going to be on show and be the star of the element like this is. So we had some really good plans in place. And I think the 2 photos tell that story. We reused the whole of the rigid insulation from the PIR board on the roof to help create this barrier around the timber. And, in one of those photos, there's good controls. There's stuff stacked out of the way. Well, we've actually got a knuckle boom in there to get up high for some of the elements, and that's another complexity in its own. But then look at the bottom photo. Now there's blue strapping on those timber posts with no protection. And I think this is the challenge that came in, is that everyone's well intentioned and everyone was trying to do the best they could with what they had at the time, and the awareness piece was there, but there's definitely a piece around, how do you tell that story? How do you get people engaged in why the protection is so important? Why you can't just lean things up against timber? Why you can't run leads around and have them dragging up against it? And I think that's the challenge with mass timber, and the parts probably adds a lot of risk to projects because people don't know how to protect them in a great way. So we moved from this sort of method to cardboard and corner protectors and foam. But I still think there's so much more to learn from that. And I've seen other ones where people have made complete plywood covers on them. And the challenge with that too is that when you start doing that in an earlier stage is the blonding on timber. So if you don't protect the whole thing, then how do you then stop the blonding when the sun hits it? And then how do you create elements where you're not bringing moisture back into the build with its own microclimate for the protection around that element? So there's still a lot of learning to do there, and I think it's something that we would still have to dig in deeper and probably talk with the industry more about how to do that. But you can undo a whole lot of work if you don't protect the timber properly. And I think the final real challenge here is the planning and cost narrative. So, and the big one that we probably learned a lot ourselves, like we planned the timber install with an inch of its life. It was like down to the minute it felt at times. And we'd done so much work front end. There was such an emphasis on how to make sure it's looked after, how to make sure that the install goes really well, how to make sure we manage it after that fact, the moisture, all that thing. And by all means, it was super successful. Like to be 4 to 5 weeks ahead on program from what we expected was like a milestone in itself. And I think that's the part that we kind of missed a trick on. We spent so much time thinking about the mass timber that we forgot about the rest of the build and some elements. We did incorporate the structural system into the building in terms of the structural steel, secondary steel. We incorporated the window suppliers and their shop drawings into the models as well. So there was a focus there, definitely. But when it got back to the normal BAU of construction, getting intertenancy walls put up, doing the linings and the claddings, getting the second fix services through, all those final critical details that you see around the mass timber, I think we went back to our standard way of constructing. And I don't think it's a bad thing, but I think there's so much more to be gained when the whole building is planned the same way as the mass timber. And I think that goes into the cost narrative as well, because there's a lot of information about there that these buildings are really expensive. And we actually decided to do the exercise of pricing this job with a steel structure. Homes went away and generated what it would look like at a UBs, at a DHS purlin system. And the thing is, when we did all that, did the wrapping around the steel to make it look a bit more attractive, the pricing wasn't too far apart in terms of the structural elements, and then everything else that followed after that was pretty straight up the same. However, you wouldn't design this building in steel like that. Like it wouldn't be done the same way. The spans are different, and the whole look and aesthetics of the building's different. So, could you build this building cheaper? Definitely. And there's an example down the bottom behind that, which is a building that's been built for a certain purpose. It's that steel girder structure, tin clad with a metal roof on it, and it does what it's supposed to do, and it's very cost effective. However, the mill wasn't going to be that. It was something different. It was changing the way that a gym was looked at. So I think it goes hand in hand. There is a cost narrative that needs to be looked at and reviewed, and I think for us, we looked at that as a risk point of view because there was a challenge around the budget, 100%. But then you had to look at that in parallel with what we were going to achieve at the end of this project. So we looked at other sort of elements that we could pretty offer up to get the cost down. And I know that the timber market here in New Zealand is really trying hard to rewrite that narrative as well as offshore. And in this situation, the decision was made to go offshore more from a capacity point of view and a timing point of view. The Europeans and at the time had a great product to market, and it really fitted in with what we were trying to do. There was a budget point as well as a delivery time frame part as well. But I think that, like I said earlier, the industry is really passionate about it, and I think for it to get more mainstream, the more of these things have to be done. From what I've gathered from the timber industry, they just want to see more timber, right? So why ideally like to be New Zealand, sometimes there's going to be elements going to work from overseas. But I think engaging with them is really, really important. I think the more that people share about the cost and what it looks like, and maybe not so much all the bad things or the challenges all the time, but also the good stuff, is what's going to help people have more confidence in going forward with mass timber. So going into sort of the last real parts of my review of this project is really looking at what we'd do differently. And I think the key element we'd do differently from number one would be engage with the suppliers early. Now, whether that's here or offshore, whatever, I think the key part is understanding who you're working with and what outcome you're trying to get. Because there's so much knowledge in suppliers, there's so much understanding, there's so much R&D, there's so much work that's been going into to try and make this a product that's worthwhile being at the table for discussion. And for us, we did make the call really late. And for whatever reason that was, I can't recall, but I think for us, we'd definitely go earlier. There's so much from sitting in the room with the people that are going to make a product and they know how it's to be designed, and understanding those key fundamentals that make the project successful firsthand. And you can build relationships through that. I think when things go, say, not to plan, then that's when you lean on those relationships. I think going to Austria and then coming back, I really felt that the passion was across the board. From Austria, New Zealand, Australia, the whole lot, everyone was really passionate about mass timber. And it's something that really sparked something in me to be like, this is a really, truly sustainable product. And people are putting a lot of effort into making sure that that story is being told in a good way. And like I've talked with the guys at Redstag really recently about their investment in sustainability in New Zealand and going to tell that story with New Zealand about how they're going to how they already are being net zero carbon production, or even offsetting the carbon, how they're doing their production manufacturing process, and also about making off-the-shelf products to making mass timber more mainstream. And that's something we did see over in Austria as well. Some mainstream glulam products are being just pumped through a factory, which is amazing to see as well. So next part, moving past suppliers, is really the job's not done when the timber's up. And I think here's a great shot of the team who put the timber structure together, and so much pride and elation about what they'd done, because it was a big achievement. This was a fantastic structure that actually went together seamlessly without any hiccups whatsoever, apart from like the snow sort of challenging us a little bit. But the team did a great job on that, and really that's something to celebrate. However, we were driven by the timber being such an important aspect that we forced ourselves to really focus on it. But that job wasn't complete. We needed to take that same level of focus to the rest of the project. And it wasn't like the team didn't do that, but I think that just doing that differently in the future is just putting the same emphasis right the way through. Because you've done so much hard work to get to this point, you want to make sure the rest of the build brings that same level of intensity. And I think for us, we created champions for the moisture management, and we could have done the same in terms of the internal fit out. I think still went really, really well, but the flow could have been a little bit different, and I think we could have had an even greater outcome than what we did. But yeah, I'm still very proud of what the team did, and you can't take away from what they've done. And this photo, I think, says 1,000 words in how they're committed to the project. And then really the last piece for me in terms of the important part of mass timber, and the part that I think stuck with me longer once the job was finished, was really matching the commitment in terms of the suppliers, the designers, the trades on site, our own team, but also the client. We had such a fantastic client on this project. They trusted us so much, and that trust definitely raised the stakes a bit. You had to know what you were talking about, and if you didn't know, you had to go and find that information out. So it forced you to start really researching stuff, forcing conversations, forcing relationships to be built. And then once you started to get into that, you start to understand what the client was trying to do. And I think that for us was the turning point of understanding, matching their commitment in terms of that. They were super passionate about this build, and they were genuinely committed into having a great outcome. And I think that's such a big difference in a project when all the team are in the same alignment, but align with the client and what they're trying to do. And the client trusts us to execute that vision. And I think, going back, that does create a drive. And I think that's shown in the way the project has come together at the end, and the relationship we have, and the enjoyment we have about talking about this project afterwards. We're still great friends with the client and the team running it. I go there a lot and catch up with them, and mostly just to see how everything is, because it is such a cool project. But yeah, that commitment, just matching that level of commitment, and be passionate about construction and the mass timber environment. So really, for me, I think I've probably allowed enough time for quite a few questions, because you probably want to know a bit more of the specifics about what we did. But I think there's a lot of people in the construction sector, especially in the timber design society sector, that have been around in this game a lot longer than I have. And a lot of them have told me the same thing. They're not here to replace steel and concrete, even though I'm sure they would like to for getting more productivity and more manufacturing. And while timber is extremely beautiful and natural, is not here to take over the construction world, it's a general part of the conversation. And I think it's moved from a genuine option in the construction industry and one that's obviously can be demonstrated and no longer curiosity of something that could happen. But it has to be in certain applications. And especially in New Zealand, where we got logistical challenges between islands and getting things around, things are going to be prevented that happen overseas. Like we've seen 1.2 meter high, 35 meter long, 400 thick Gululand portal beams getting transported around. And that's potentially not feasible here. However, in Europe, it's easily achievable. So I think for the mill, the application was perfect. The skeleton structure worked. It did the heavy lifting, but also looking amazing. And the team was really looking to create something different that was previously offered as a gym. And I think you can see from this photo it does. The timber provides a sense of warmth and character. And those that train and work and recover there, they can feel that when they walk in the building. And to see people watch them as they come in, they look up straight away. It's a pretty amazing experience to sit back and watch. So I truly believe that the best buildings now and in the future will be the ones that use materials intelligently. I think sometimes that's going to be mass timber throughout the whole build. Sometimes that's going to be a hybrid. And then other times it's going to be concrete and steel. The answer isn't always going to be timber. But I think the question is, do you understand what each material does? And are you going to design from that perspective? So for me, the greatest lessons I've learned are from the relationships that I've built during this project. All the stuff I've talked through today around, moisture management, protection, the planning early, the BIM, the client, the whole lot. It all hinges and comes back to a foundation of a great relationship. I think there's been decades of insight provided in terms of this time I've gone through and found out all this information from just talking with people. And that when people are passionate about something because they're willing to engage and they're willing to share. I think that's something that is so key to the success of mass timber in New Zealand and obviously worldwide as well, is this passionate people. People need to be passionate about its adoption. They need to be passionate about testing themselves and getting out of the comfort zone and trying something different and not being afraid to ask questions. They don't need to know everything because there's a massive society of people who actually know elements that can help. I think the one part that I'd stress is while it's incredibly nerve-wracking having to talk about a project and share that information, it needs to be done more. Because we want to show clients that it's no longer just a conversation, it's actually a real thing that can happen. And I think this project stands as a testament to that with the right team, the right client and the mindset, and obviously the ability to engage, you come up with fantastic options. So I thank you for your time today. Thank you for listening to me prattle on about something that I'm incredibly passionate about and love as well, this project. And I suppose I'll now hand back to Bjorn for Q&A.
Yeah, thanks, Josh, for an amazing presentation and for letting us into the insights of your experience with that and the challenges as you described that you faced, and probably the challenge as well presenting it and talking about it openly and transparently, which is rare and we should be doing more often to get better timber buildings or buildings in general. But we've got about 20 minutes. We've got a few questions, so let's kick it off. The first one is, can you confirm whether thermal movement has been considered in the timber beam design, particularly in the relation to fixing and connection detailing? Are you aware of that being included? Because different movement of timber versus steel and how the different temperatures would have affected that on site, especially being delivered from overseas.
Yeah, I think there's definitely a real technical question that would be better answered by someone from Homes, but I suppose what I can talk into is the experience from ourselves. we had about 2 mils tolerance around the steel for the plates in terms of the steel plate from both top and bottom, and the glulam scarves that were created to slide the timber in and out of. So not a lot of tolerance. But what I do know is that for the moisture management, we were starting around about 12% moisture content when it left Austria and then got to New Zealand and then down into Queenstown. And to the worst part of it, it moved up to about 13.8%, I think. So in terms of moisture content increasing when you're outside, it hardly moved at all. And what I would say is normal. I've built a lot of houses where you start on site with 12% sticks, and then the rain comes in and you get 20% sticks and you fail your pre-line, right? So in terms of this build, it didn't move at all in terms of what we're saying. So there was limited room for error in terms of those scarves, but we didn't have any challenges really in getting those on and off the steel. We did have some stuff right at the start where when we got the steel welded, it kind of twisted just ever so slightly, and that did create some challenges for us that we had to kind of navigate, which was getting them just slightly adjusted. When you're heating up steel and welding it just slowly warped a bit. So there was a bit of work getting those in and getting them readjusted. But once we got those sort of ironed out really early on, the next ones coming through were fine. But yeah, and then going into operating now, there has been a little bit of movement, which is standard with timber buildings. There are some cracks appearing, which is standard. And talking with the guys, or everyone in mass timber who knows, like the joints are really, really strong, right? So the fibers in between those joints on the lamellas, some of them are sort of opening a little bit, but we're talking about less than 3-4 mil. So it's not like structural integrity is having a challenge. There was one area we had to do some extra screws were put in, just more so just from maintenance point of view and watching that element. But yeah, overall tolerances with their design for the building obviously to do what it needed to do to move, but for an installation point of view, it was pretty tight tolerances. Yeah.
So you would say the temperature differences and the tolerances there were provided didn't cause you to have tight joints, and you had to wiggle the plates into the timber and try to bash the bolts in as we see it sometimes.
Yeah, no, I think on one of those photos, if I bring it up here, you see the guys have got this bar obviously to align. We assembled quite a few elements on the ground to make it easier. So you can see that's obviously a V for a top, so a section like that. So the team assembled them on the ground, which made it a heck of a lot easier as well. So the bottom parts are obviously the challenging parts to slide in, but like I said, potentially the weight element of it as well, but it wasn't like big, massive mallets coming in and bashing this thing into position. It's a finished product, so we're trying to treat it with that kind of care. There was some jiggling and moving in that, but nothing of extreme where you're actually physically smashing something or getting a chainsaw out to cut the scarf bigger.
I've got a longer question here, which is partially a comment. And the question really that is asked here is, what were the foundations of the mass timber structure buildings? Were these raft concrete foundations or pad foundations used here? So the person just wants to know with different soils and probably weight ratio gains and other footings to think of, but what was the foundation on this building here in particular?
Yeah, it's a great question. So the challenge on this one was going to be not the weight dispersed on the ground, which was keeping the building from lifting up. So with the saws we had here, we actually had to put a whole lot of rods down into the ground. So drilling a whole lot of rods to actually create some strength to keep the building locked in and grounded. So ground anchors, I think, where they came in and drove a whole lot of those into the ground and the foundation. So there were obviously it was a raft foundation. So we had ground beams running through with mass concrete, obviously, where the timber came into those hold down bolts, hold out plate connectors. But yeah, it was a raft slab essentially built up. So we poured it in two large pours right the way through. So split it right in the middle. and then created these rib raft sort of style foundations. So don't know the mass of that concrete of what it was to. I'm pretty sure we're about a metre deep sort of raft on this one, and that had a lot to do with our ground conditions and gravels and stuff there, alluvial gravels here. So there needed to be a bit more weight distribution across that. But yeah, essentially similar to those other projects, I suppose, from a steel element, but there was definitely those extra pins had to go down just to keep the building locked into the ground.
Locked into the ground, and let's lock in the next question. So, one thing that we probably wondered that was going to come, I might have missed it in the presentation, but what was the reason for importing the timber from Austria? Was it the size limitation for the manufacturing, or was it a different reason that was that leading driver to import the timber from overseas that
Yeah,
time?
time frame there. So yeah, we knew this question would come up. So for us at the time, it was a capacity challenge around sort of where the market was at the time, and obviously us looking for the best for project across the board. We suppose for Cook Brothers, what we're trying to do is always keep the client front of mind of how we do things. We kind of treat it if we're a developer, what we do. So we're not afraid to go offshore for stuff. We'd like to do New Zealand where we can, and that was definitely the driver from everyone around the table in the early stages of design. But as you got further through it, yeah, the capacity sort of elements as well, and then just what we felt was at the time Europe was definitely looking to get into the New Zealand market as well. So there was a competitiveness there in the market as well, which came in. I think for us, it wasn't like it was not going to happen, but it definitely made the job a bit easier when the numbers started stacking up a bit easier for us in terms of that. But you know, I've had those conversations with the New Zealand market after that. We've been very upfront and talked through what those challenges were and where we were in terms of position and where they were as well. And so I think there could have been things done on both sides as well to help with that. But to be fair, like I went back to, is that I think everyone's who's passionate about mass timber wants to see more done. So I think by having jobs done, whether it's here or offshore, it does help tell that narrative. But I know that New Zealand definitely wants to be, you know, more at the forefront of that, and we support that as well.
Oh, that's wonderful. Having done this project now, would you approach costing and contingency differently for another timber building? Would you bank on the reduced timber structure erection program? Good question.
Yeah, it's an awesome question to ask the builder because we're always trying to protect our program, right? And it's hard. I think what we'd do differently is look at the building as a whole. So, you know, so yes, we definitely would look at our contingencies and how we approach the methodology. Would work more in that digital space and probably go 4D in the BIM space of trying to program out the program in the BIM space and start looking at that sequencing of timing. We've got metrics now on how long it took us to install a beam, for instance, and how long it took us to choke them and put them together, the bolts, the connections. But I think with that, you've got to really look at your methodology too. So for us, the move to having the purlins manufactured off-site and all checked out, ready to go. So they were just slotted in as they went. That was a real massive speed part for us. And also talking with the structural engineers, and this is irrelevant for mass timber or not, we worked out how far we'd have to go before we could release the propping. Because releasing the propping obviously allowed a lot of room around the rest of the building to carry on. So looking at tying in all the reed bracing and that in the roof to strengthen up the structure allowed us to then release that, move that propping down, and then start on the next phase of the works. So I think I don't think the program would have gone potentially any quicker than what we did, even with that benefit. But I think what it might have changed is how we approach the rest of the build. And if we approach the rest of the build with this mentality, then there definitely could have been benefits in the program savings. So, and I think that's something we're challenging ourselves on, not just on mass timber across the board. Like get into the digital space, look at the metrics, start running those back against previous data you have, and then looking at what does that do for your contingencies and risks. And it goes back to your relationship with the client as well, understanding that relationship and being transparent on where things are at. And then maybe that shared risk, if you haven't done it before, is like how do how do you be upfront about that shared risk? And if it comes under hours, then what does that look like? If it goes over hours, what does that look like? So I think those conversations are the key parts as well, especially if it's a first time build or you haven't done a structure like this before.
I think it comes back to being honest and open and transparent about in the realm that you are allowed to share information. And I think it should happen more often, and then that'll make it easier for others as well. And the pricing then will probably be low as well because it's not as much risk perceived to be related
Yeah,
to doing so.
definitely. I think
Um,
Bjorn, just on that one, it goes back to that the right project, right application, right? So, and I think that's something that's going to be really taken into consideration as well. Don't try and design something in timber that potentially is not going to work from day one, from the perspective of the client's budget. Knowing those numbers, and I suppose it's chicken and egg, but even if you've got to go and get some work done by the mass timber guys about what it would actually cost for structure of certain size and getting that done early rather than getting all the way down the path finding it's too expensive or getting that budget done really early that's based on theoretical information that blows it out of the water before it's even started. So
mm, yeah, definitely. And you just mentioned size. So the next question is actually about the length on the individual parts of the mass timber. So how did you deal um with the overlong length, or were all members less than 12 meters, so they were fitting into containers? So how did you address that?
yeah, so everything had to fit inside a 40-foot container. Uh,
Mhm.
Luckily, the design was factored around that really early on. I don't know if it was by choice or not, but I think that was the same design intent anyway about what you could shift around New Zealand easily without piloting vehicles and that sort of carry on. So the intent always was to make it inside a 40-foot container length to make it distribution around New Zealand easy. So yeah, obviously depending on where your project is in New Zealand, it would depend, how close you are to the source about what you could make and how you design that. But this was all made around that container size, and to be fair, it did make it easier to handle when they weren't like humongous elements. And I think the grid lines that WAM chose really early on was such a key aspect, and I think that really early concept and understanding what the limitations were from and them designing to that was like fundamental, and it's been successful.
So I think there's two things we can combine here. So one is, what is the lifespan for those timbers? And the next question that will build up on that is, what does the long-term maintenance plan for untreated timber look like? So I think they go both well together. And how does this get tackled during design and even construction, and what's going to be done in the future?
Yeah, great question. The lifespan, I don't want to say the wrong information here because I haven't got the information on hand. My my gut feel, I'm pretty sure it's 50 years, like a traditional commercial building that has to stand that long. But I don't want to be wrong in saying that. So potentially it's something that I could come back on with homes later on and what they actually got us to build to. The long-term maintenance plan. So it's a great point talking about the untreated timber. So for this one, we engaged a building environment envelope specialist to actually do some modelling on this timber to make sure that it could be untreated. Um,
Mm,
and so that modelling really early drove the decisions on going away from a treatment. And the client really wanted an untreated building because of the feeling and what they're trying to do around health. They didn't irrelevant of what whether the narrative around treated timber. They wanted a natural product for them, which was natural meant there was no preservatives being putting on it from a treatment level. So the products we applied were natural products. And then that longer term maintenance aspect on this one, internally, we're just doing checks on it, continue looking around, monitoring any movement in the timber. Is it something doing continually? Keeping it clean is probably the key part as well. And luckily, we don't have any real elements where the dust is going to sit in there for a long time. But yeah, from that part internally, there's nothing more than you probably do for a timber cladding, essentially from that aspect. Externally, once again, it's just a monitoring and maintenance sort of aspect, reviewing that timber on the outside. At this stage, it's been there a year, and those outside beams are performing really, really well. We made sure when we designed it to ensure that there was protection for the end grain as much as possible, and that it wasn't all completely shown. The benefit of this too, it's a east facing that side of the building. So the other parts of the building that are not mass timber are kind of taking the brunt of that elements from the weather. And also you'll see under the soffites, they're a mixture of fiber cement, Ecotech, or I think is the product, or a similar, like a color through product, and then a coir batten. So they've got a treatment on them as well. But they're going to be left to naturally silver off. So the coir is. So yeah, from that element, yeah, having that science done really early on gave us confidence about how we're going to manage that moisture inside the building, and that did kind of play into also the mechanical systems and how they're going to operate to keep that temperature at a stable temperature. I might as well share the wee secret. The post to the far left of that picture, that's actually steel. We couldn't get away from that one being untreated. So it's a steel post. It's been wrapped in Nordic pine with a treatment on it, like a clear coat treatment on it, to like you would a cedar. And that's going to have a maintenance probably every year, every 2 years of just continually doing that maintenance on that one. But that's more like cladding rather than a structure. So the one doing the work is the steel behind the scenes. So, but yeah, I might as well share that little secret there for the design team. So, when you have to incorporate stuff like that, I think you can work around it by thinking a different way. And yeah, in that instance, a wrapping of that timber was the best option.
And I think, well, there's always other more durable species. However, they might be more pricey. They would be dearer. And as you said at the beginning, you don't have to shoehorn timber into everything. So if you have a solution that works more efficiently and provides the durability and the safety, then that's the goer. So no, that's great. The next question is about control. So you touched based on that already. Climate control systems in the building, are they any different than they would be for a steel structure? And the heating, cooling, moisture ventilation for the gym, were these all hung for the timber structure, or did you have to implement other, other members and other materials potentially that were coping with the loads?
Yeah, great question again. So the internal sort of sock, we'd call it, is the one that delivers the cooling essentially for the gym. The problem with the gym is not, which I'll bring up this photo so you can see it. So this up here is the white sock there. That's sort of distributing the fresh air through the building. There's also ground level and high level windows on actuators that then can be opened and shut on the BMS or manually. So as the building starts to heat up too much in part of the day, or they want a fresher air coming through from the air coming out of the socks fresh, but it's like that feeling people have of just a breeze coming through, they can create that. But so that sort of deals with that sort of internal environment. They've got some big fans as well on the mezzanine areas where there's two workout areas that can distribute that cooling or heating around. And then there's a mechanical system that runs in the background of that as well. So all the lower level where the consultation areas are, which is in front of the building on the slide here, they are all done with sort of traditional heat pumps on the walls, running off split units back off of all the plant, which is actually hidden up on the roof. But going back to that photo again, you'll see in some of those beams where there is some structure or some heating panels hung off, those radiant heaters, they've never been turned on.
Right. Okay.
The client actually, or the gym owner goes, "Can we sell them off? Because I don't like the look of them." But the building is performing in such a great way. It's got a warm roof system and a warm wall system, and then obviously double glazed, thermally broken windows on the ground. Like it's a very high performing building from a heating and cooling perspective. And so yeah, those have never been turned on. So in terms of that element, that sock does a lot of the control in terms of the heating and all the cooling elements more so, and putting fresh air into the building. And then yeah, the structure, this timber is where it's hung from. So quite a light structure, that sock as well.
Yeah, no, just coming back to the question as well, do you think in a steel building that would have been any different, or have you had any experience with previous gyms just a warehouse, do you think this white sock would have done the same job? And would the climate be similar because you would have implemented similar insulation on the outside envelope, or is it any different?
Yeah. It definitely would have been different. I think you'll go potentially to a rigid duct potentially. We did the Wanaka Aquatic Centre in Wanaka with WAM, and this is what we used over there as well in the pool, the sock method, corrosion and all that sort of carry on over there, and it's a good option for this sort of environment, where it's light and it hangs really well. But yeah, I suppose the building I was talking about, that sits behind the mill, the steel building. And it's incredibly cold in there, for working out as a gym, freezing in winter, and it's got big steel ducting and stuff carrying on. So I think it's horse for courses, right? So depending on what your outcome is trying to be, if you are trying to create an environment like this where it's not just about a gym, there's a bigger discussion at play about world-class facilities and temperature controlled, and then the clinical side and the recovery sides, then yeah, you definitely would be doing a structure like this, and running services in this way. But if you're going to more of a traditional, say, gym with maybe without a ceiling in it, and it's all steel structure exposed, because that's the look that they're going for. And I've been to a lot of those myself in terms of CrossFit style boxes and stuff like that. You're going to go very, just a raw steel element, I reckon. So, and I think it's just, once again, horses for courses.
No, great. I think we're out of time, and there are still some questions left, so we'll try to send them to you, and you might be able to answer them. Maybe one that we can sneak in shortly. Where were the steel connections fabricated? So can you just disclose that quickly in one sentence?
Yeah, so New Zealand. So that's VIP in Christchurch, and they did the secondary steel and all the steel connections. So yeah.
And then very quickly, also, was the CNC cutting bang on, or did you need to squeeze every now and then on site and re-drill holes?
No re-drilling, no squeezing. There was one cut we had to do where one had just been missed off the detailing. So there was and it was only talking about one line of a line, maybe 300 mil long. So yeah, but everything else bang on. No challenges whatsoever.
Wonderful. All right, there's a longer comment which we can't unfortunately get to it, but thanks for the comment and the question. Thanks to you, Josh, for sharing all the um, experience and for answering all these questions and for yeah, some tricky questions that probably we get asked very often in the industry, and sometimes it's hard to answer, but really appreciate your time today. And thanks for everyone joining in, listening today, and see you at the next TDS webinar in the next month. Till then, have a good time and stay safe.
Excellent. Cheers, Bjorn.